Hi guys, Corey Mulbauer, R&D agronomist again. I'm here to talk about closing systems in this last session. I want to get started with relating the management practices and the concepts of a professional sports team to how it interacts and relates to business in general as well as business and farming. You see, there's a manager of a professional baseball team, and his job each and every season is to evaluate the talent on his roster. Each and every player on the roster is selected for a specific job on the field, and so that job requires specific talents and capabilities of each one of those players. So he's looking at his roster ahead of each season, and he's going to evaluate, do I have the right team assembled to basically get the goal and achieve as many wins as possible day in, day out throughout that next season. This is very similar in the business of farming, especially with the planting pass. There's a lot of technologies and a lot of components and systems that we have to assemble and put together to make sure that we have a winning team when it comes to being successful with the planter pass. So you need to ask yourselves, with your equipment, do you have a winning team assembled? Basically, day in, day out, you want to achieve the most wins possible. There's one player in particular that has a special role on a baseball team. His job is to come in at the end of a hard-fought close game, like this one that we're illustrating here. The Yankees are up 6-4. It's the 9th inning. The player on the mound, his job is to get the last 3 outs to bring home the win. 93-mile-an-hour fastball, that's the 3rd strike of the 3rd out, and he's done it. This player not only is very important to the team, but he has a special name on the team. He's called the closer. The closer is so much of a guarantee to bring home the win and get those last 3 strikeouts that he doesn't play any other role of the game. His job is to wait until the end of the game and they bring him in just to get that win. And not only is number 42 on the screen just one of the closers in the league, he's the greatest of all time closers in baseball. Mariano Rivera has over 600 saves in his 19 seasons as a professional baseball player. Now we're back in the planting environment. It's the 9th inning right now in planting. All of the teammates, all of the systems on the planter have done a phenomenal job of setting up the win in the game of planting. Who is your closer going to be? Who have you selected to bring home the win in this environment? There's a lot of options to choose from when you're looking at closing for your planter. The industry, equipment industry, has created all kinds of variety of wheels and spikes and tillage options for the back end of a planter, and they all have unique and special characteristics. It's very difficult to choose from what's out there. They really can be summed up in about 4 different types. One type being a spike closing wheel, and that is primarily designed to do a lot of tillage and chew up the sidewalls. There's rubber closing wheels or smooth wheels in general, and they're a press style that pushes on the soil from the top, closing the furrow from the top down. And then there's poly spikes or hybrids between spike and rubber wheels that are also in the market that do some action in between the spike and the rubber. There's disc closers who slice into the soil, and with concave discs, they kind of fold the top end of that furrow closed, and that's the way that they work. Since 2013, R&D at Precision Planting has done extensive research on closing, and so I'm going to share some of our learnings and experiences from all of that research. One of the things that challenges any given closing system are 3 environmental factors that are different on everybody's farm and different throughout a season. We have soil variability, which is basically the sand, silt, and clay content in your soils. We also have organic matter variability that changes the way closing systems perform. There's moisture variability, and this has to do with the weather patterns that we're dealt with. And it changes seasonally as well as week to week as different weather systems roll through. We might be planting in wet conditions one day and dry conditions later in the season. The third is tillage systems. Most farms have a variety of tillage systems from field to field. Some no-till, some conventional till, some strip till. And those are all environments that change the performance of a closing system. We're going to evaluate some of the data we collected from our research. We took a number of field trials and we grouped them into the conditions that the soil was in the day that we planted the test plots. So here we're looking at dry seedbed conditions, so moisture is limited. And the data is the ear count potential. This is our emergence score where we go out about V3 and we evaluate the uniformity of emergence and we come up with a number of plants that are going to produce a full-size ear in corn. Our goal is to achieve 96% or greater ear potential from our emergence counts. This dry seedbed condition, we notice some trends happening. On the left side, the worst performing options on the closing wheels are aggressive spikes and disc closers. One's designed to do tillage around the furrow. That leaves the soil too loose in a dry environment and that hurt the ear count potential on our emergence score. On the right side, there's cast wheels and rubber wheels are performing the best across this type of environment. They have the ability to press and firm the soil down and help in this environment. We flip over to tough seed beds. Tough seed beds are soil environments that have high compaction risk. It's challenging for a closing system to move the soil and do a good job putting it back around the seed. When you look at what the winners and losers are in this environment, the rubber wheels, which was the best wheel in the dry seedbed conditions, are now the worst wheels in the tough conditions that we're trying to close. Lightweight spikes and other things are also performing poorly. Those disc closers are stayed in the bottom end of performance as they did in the dry conditions as well. On the top end for the tough environment, we have spikes, but not just any spikes. These are heavier spikes. They're made out of cast material. They have a greater ability to take action on those tough sidewalls and close that furrow. So things that are heavier and more aggressive are on the right-hand side of this chart. And then we look at all of the ideal seed beds. The ideal seed beds are the soil environments that really were pretty easy to work in. The planter was performing very well and there was no challenges for a closing system. And then really all closing options worked pretty well here. And I think this is why as farmers, you guys struggle to choose the best closing system on your farm because quite often you're in ideal conditions for planting and your current system is performing very well. So it's hard to evaluate where could you improve when sometimes what you have is performing at its best. There's a lot of options and things you need to evaluate when it comes to adjusting closing systems to make sure you're doing the best job you can with what you have. You have to choose a down pressure setting. There's 5 settings on a tail assembly for closing. So what pressure is right? If you're too light, like in the picture on the right, you may crumble the top of the furrow closed, but the bottom of the furrow is left open with an air gap around the seed. If you get the pressure correct, you should see all of the soil put back together around that seed and a good environment for germination. The width that you set your closing wheels at is very important to get right, to help do a good job. If you're set wide like these rubber wheels here, 2.5 inches apart at the narrowest point, you're going to have a wide stance over the furrow, which tends to only close the bottom and leave an open slot on the top. If you set your wheels too narrow, the opposite occurs, and you tend to just crumble the top of the furrow closed, leaving an air gap at the bottom. When you get them set correctly, and I found that that's about 1.5 inches in width between the narrowest points at the bottom of the wheels, you will more often get full closure of the furrow from top to bottom. The 3 goals of closing that I've learned that we want to achieve is we want no slotting or air gaps in the furrow around that seed. We want to optimize soil density, and this is something that was new to me that I uncovered, that setting the soil density is actually a tool that you have in place by choosing the right down pressure on your closing system. You see, you want to maintain a mellow path to the surface for emergence. We want quick emergence, and in wet soil conditions, this can be a challenge. In drier conditions, we want to preserve moisture and achieve moisture retention, and so you're probably going to want to run a higher down pressure setting on closing. We also want to leave the surface of the ground level after the closing system is done. So how do we evaluate what we have and how good a job we're doing? We need to look at how our closing is performing. You're not going to be able to do that from the surface of the ground walking behind the planter. You're actually going to have to dig below ground and see what the environment is actually around the seeds themselves. So I'm going to share some of the experiences from digging behind planters in many different fields that I've learned over the years. I like to dig with a garden trowel. Like in the video, I dig the same direction that the planter ran. And this basically is exposing the furrow from the top down, and any of the imperfections show up, like the air pocket that we uncovered here. As I'm digging, I'm also trying to maintain a furrow environment wall so I can get a perspective of that vertical profile of the furrow right around that seed itself. This is going to give you a look at the density of the soil that you've placed that seed into, and also another look at any types of air gaps or slotting. When you find slotting behind the planter, the seeds may grow, but the risk comes later, and that is when the roots start to develop. Roots can't develop in open air. They have to have soil contact and moisture. And so you could end up with rootless corn, or if the roots do grow, they'll be trapped in this slot and you'll end up with hatchet roots, limiting the yield potential later in the season. If you expose air pockets as you dig down into the furrow, this is a problem because the seeds may germinate in the air pocket, but they'll get trapped below ground. They won't have the ability to push through to the surface when they're trapped in an air pocket. Soil density is a big factor to keep in mind. And again, this is how you want to be thinking about how much pressure do you want to apply with your closing system. In this video, we're digging in a strip till environment, and notice how soft this ground is as we poke the knife into the soil. If you have this kind of environment, you should be very nervous that you may dry out before the seeds can germinate, or have zones of drier and wetter soils where you could have uneven germination and emergence. This would be an indication that you want to run higher pressure. When you're digging in the furrow environment and looking at this vertical wall profile around the seed, what you don't want to find is, as you're picking away, if the soil crumbles in very easily, then that's an indication that the soil density is way too low and you're at risk again of drying out that seed environment. So you'll want to carry a higher pressure setting for your closing system. If you're finding soil conditions that are too dense, too compact, as you're digging in that environment with your seed digging tool or pocket knife, you notice that the soil is very tight and it's hard to dig, and it doesn't really move much as you're poking at it. You have to push harder to get into that soil, and that's an indication that it's been over compacted. You typically also see a slot or some evidence of where the disc openers cut through that soil, even though the closing system has pushed it back together. If you get the soil too compact or too dense, you're going to lose some plants because they won't have the vigor or the energy to push to the soil surface through that compacted soil, and that's going to be a yield hit later in the year. Optimum soil density when you're digging in that furrow environment should look like this. You want to see a vertical profile furrow wall that can stand on its own, but yet if you dig around in it, it should be easy to crumble away and dig. But when you stop digging, it should again stand on its own, indicating that you've got a good balance of soil density for that seed to grow in. It's going to retain moisture, and it's going to enable easy path for emergence. Furrow Force is a closing system that we developed at Precision Planting, and it's been out for a full season with a number of farmers running it in a wide variety of conditions all over the country. We built Furrow Force to attack all of those challenging situations that other closing systems struggle to perform well in. Furrow Force is designed to close the furrow from the bottom up. It's designed to fracture and lift the sidewalls. It's designed so that the operator can set the soil density exactly where they want it to be for optimum emergence and water retention. Watch this video as Furrow Force is running in the field. You can see with the disc angles up front how they're cutting in, closing that furrow from the bottom up, and that wave of soil being lifted through the center of those wheels. And then the second set of wheels on the back are tamping it down and creating that optimum soil density to create that perfect environment. So farmers all over the country are seeing great success in a variety of conditions, like this picture of no-till clay ground, conventional till sandy loams, no-till loam soils, Pretty much every environment that's out there, Furrow Force has done a good job. And we get one common comment from all of those Furrow Force customers, and that is when they dig, they can't find the furrow. And that's really what the goal of a good closing system should be, and Furrow Force achieves that. There should be no evidence left behind that the row unit put that seed in the ground. We shouldn't be able to find any evidence of gauge wheel or disc opener interaction with the soil. It's as if the seed somehow magically just got placed 2 inches below the soil surface. So Furrow Force is the closer you want on your roster. It's the closing system you want to bring home the most wins day in, day out throughout any planting season. So next, I'm going to turn it over to Tristan Herman. He is a Furrow Force engineer. He's in the R&D shop, and he's going to share some of the features of Furrow Force on a row unit. Tristan?
All right, thanks, Corey. My name is Tristan Herman, and I'm a design engineer here at Precision Planting, and I am really excited to get to talk to you guys today about Furrow Force. But before we dive into the product itself, I want us to think a little bit about, what are we exactly trying to accomplish when we think about closing the furrow? We've been researching closing for almost 10 years now at Precision Planting, and through our research, we've discovered about 3 main goals that we want to accomplish when we close the furrow. The first goal is when we close, we want to make sure we don't leave behind any slots or air gaps around the seed. So we get a nice, even germination of the seed itself. Then 2, we want to leave a mellow path to the surface above the seed so we can emerge the whole crop at the same time for that uniform emergence that we're all looking for. And then 3, in some of our looser soils that are more prone to drying out, we want to make sure that we can preserve moisture in those looser soils. So again, that's no slotting or air gaps, mellow path to the surface above the seed, and moisture retention in loose soils. So when we look across the industry today at the closing systems that are available, we really found through our research that many can accomplish one of those goals, maybe 2, but never 3 at the same time. So Furrow Force was created out of a desire to achieve all 3 of those goals of closing across a wide range of field acres and conditions. Furrow Force is a 2-stage closing system with integrated sensing and automated control. The first stage consists of the notched wheels. Now these first stage notched wheels are cambered both down and in. So that means the closest point between the wheels is at the bottom. And this allows us to attack the furrow from the bottom to the top, closing all the way from the bottom to the top, which is something that has historically been a challenge for disc-style closing systems. These first stage wheels are also open-toed about 2 degrees apiece. So that combination of camber and toe allows us to lift and fracture the furrow from both sides. And then the notches on the wheels can churn up the sidewall compaction created by the opening discs and the gauge wheels. This ends up leaving us a nice mellow path to the surface above the seed. So once we've come through with our first stage wheels, we then finish it off with the second stage stitch wheels. Now these stitch wheels level the surface above the seed and also press out any air pocket that may remain around the seed and stitch the top of the surface of the soil together. The second stage wheels also manage soil density around the seed by preserving moisture in looser conditions. So the first and second stages are rigidly linked together. And what that allows is for the second stage wheels to act as a depth gauge to the first stage, which we want to be running at about 1/4 to 1/2 inch above seeding depth. And in the middle of that rigid link, we have placed a gauged load cell, which is outputting to us at all times the amount of load we are carrying on these second stage wheels. So this combination of the rigid link between the 2 stages and the gauged load pin can tell us that if we have positive load on these second stage wheels, we know that the first stage is at full depth doing the closing action we need of lifting and fracturing the soil, and then we can come back and finish it off with the second stage. So now that we have this measurement of how much weight we're carrying on these second stage wheels, we can take that to use it for automation. And we utilize our Furrow Force control module that sits right on top of the airbag here to maintain a consistent amount of weight on these second stage wheels at all times. There are so many things that can affect how much closing action you get from a system that is only statically applying force all the time. When we think about conventional till versus strip till versus no-till, each of those tillage systems require a different amount of closing force to really close the furrow. Speed is something we've researched a lot here at Precision Planting, and we've discovered that even a few miles per hour of additional planting speed requires a huge amount of additional applied closing force to truly close the furrow. Also, soil type. We know each of you have different soil types within the same field, where you may be going from a loose sandy soil to a tight clay within the space of a few hundred feet. And you need a closing system that is able to adjust and account for that soil type variation. And with furrow force, we take that all into account, where we utilize the gauged load cell and the control module to maintain consistent pressure and consistent weight on these second stage wheels throughout all of your field conditions. So what does it look like to run furrow force from an operator's perspective? When you have furrow force with the integrated sensing and the automated control, we provide closing related metrics to you into the cab through your 2020 Gen 3 monitor. You'll see metrics like ground contact on a row by row basis reported up to your 2020 display. You'll also see things like detailed spatial maps of your closing margin. You can also set from your 2020 display how much weight you want to be carrying on these second stage wheels. And once that information's set, you can have the confidence to know that furrow force is going to be working constantly to maintain a consistent load on the second stage wheels, keeping those first stage wheels engaged throughout the entirety of your field's variable conditions. So that's furrow force in a nutshell. It's a two-stage closing system with integrated sensing and automated control, which makes it simple to achieve good closing performance. In 2020, we had a fantastic planting season in furrow force's first year of limited commercial release, and we are super excited for what the 2021 season has to offer. So now I'm going to hand things off to Jason Webster, who had the opportunity to run furrow force, and he's going to share his amazing plot results.
All right, well, thank you, Tristan. As Tristan said, my name is Jason Webster. I'm lead commercial agronomist for Precision Planting, and I manage and direct the PTI farm, the Precision Technology Institute in Pontiac. And today you've heard from Corey Mulbauer and Tristan Herman about closing, our experiences with closing the furrow. And I'm going to extend on that a little bit more. I'm going to talk about our trials that we've done, the testing that we've done at the PTI farm, again in Pontiac, Illinois. And today I'm going to ask a few questions. And probably the resounding question is, does emergence timing matter? We're going to talk about planting corn today specifically, and we're going to talk about, can we get all the corn up at the same time, uniform emergence, as a result of the perfect closing system. We'll talk about the race for fast emergence. Can we, in fact, get all of our corn plants up within the first 12 hours? We'll spend some time talking about that. And then we'll compare furrow force to some other closing systems that we've tested at the PTI farm. So the picture you see on the screen, this is the result of a closing system that didn't do a very good job. It left an air pocket. You see that green seed down in the furrow? What's it surrounded by? It should be surrounded by soil and water. What's it surrounded by? It's air. It's an air pocket. That closing system never got that air pocket out. It didn't collapse that trench. And so now we've got a seed that's surrounded by air, and now it can imbibe water to germinate and ultimately get out of the ground. Now it might germinate, it might get up out of the ground, but it's going to take a rain. We're going to have rain go through the soil profile to that air pocket and collapse it, and then the seed will have good seed to soil contact. It'll imbibe the water and it'll germinate. But there's a problem with that, and it's time. By the time that corn plant gets up out of the ground, it's going to look around and it's going to say, well, wait a minute, I got two big brothers on each side of me, and those big brothers are always going to be taller in size, more mature, larger root systems that are always going to be hungry for water and nutrients, and they're probably going to win versus this little runt of a seedling. So what we're going to talk about today is there a penalty for these late emergers? Okay, and then ultimately, can we get all of our corn plants up at the same time, again, for that uniform emergence? So, is there a yield penalty for late emerging plants? If that answer is yes, I want to know what the cost is. And then lastly, I think we need to figure out how often is it happening in the field so we can put a true economic picture to this situation. Now, the closing systems that we're using at the PTI farm, we've got 5 total. And here's the first one. This is a situation, or I guess a simulation of a grower having those OEM rubber wheels that we've been using for decades, right? And this would be a simulation of a grower saying, you know, I don't know if those rubber wheels are doing very well for me. Let's take one of them off and put one of those lightweight plastic wheels on, those notch wheels, those spike wheels. And this is a Yetter poly twister. This is a really popular closing wheel, I guess, in the industry. But this is just putting one of those on along with the rubber. Then the next closing system, we say, let's remove the rubber entirely, and we go with a dual plastic notch system. And these are dual Yetter poly twisters. Again, a very popular closing system across the country. Third, we're going to go a little heavier. I want a well-rounded program when it comes to closing systems, and so we've shown you the lightweight wheels. Now let's go heavy. This is from Martin-Till. This is a dual dimple wheel. Again, a very popular system in the marketplace, but it's heavy. One of these wheels weighs about 35 pounds with the hub and the bearing. You put two of them on the tail of a planter, and now you've got a 70-pound system, much heavier than the two we talked about earlier, those plastic notch wheels. And then lastly, we're bringing in the fingers, those cast fingers. This is a Yetter cast finger along, working in tandem with one rubber. So this is popular, especially for guys in the past that have gone to reduced tillage, getting those fingers in to lift and fracture for them. But again, I wanted to look at the fingers, I wanted to look at the heavy wheels, and then I wanted to look at some of the lightweight plastic wheels, all in comparison to an automated furrow force system. So that's what we're testing at the PTI farm. Now, we put all these systems on one of our plot planners, and we went out this spring and we evaluated all of these closing systems. And you can tell by the video right now that we're in conventional till, so I want to preface that. All the data I'm going to show you here in the next few minutes is from conventional tillage. So we're out there planting, we get done, we wait about 100 to 110 heat units later, and that corn is just ready to poke through the soil surface. And our team at PTI, we're waiting for it, okay? Because we have a flag system that we put into protocol at the PTI farm. Here's what happens. When that corn is just ready to poke through the soil profile, we're there with a flag to mark it because we want to know when it came up. Remember what we talked about earlier? We want uniform emergence, all of the plants coming up at the same time. But what if they come up in different segments of timing? So when the first few plants come up, we flag them and we mark them. And we go to the field every 12 hours and we will re-flag or remark any late emerging plants. We're going to measure them at 12 hours, 24, 36, 48, and then we have one category at the end that is anything after 48 hours, okay? So if you come to the PTI farm in the spring and you see some of the block testing that we've got with closing, testing this uniform emergence thing, you'll see flags that look like this. And remember, we want uniform emergence, and so when we flag these, we'd love to have one flag color throughout the whole row. And if you look at this picture, how many times do you see that? In this block, we don't see it at all. So that tells you that we've got a difference in emergence timing. So this is an area of the field that I went to. Okay, you can see the red arrow pointing to the flag, the steel flag we put in the ground. I marked that corn plant on the right 12 hours ago, okay? I come back another 12 hours looking for new plants, and that guy right on the left, that's a new one. That's a 12-hour difference in emergence timing right there. Now, as a farmer, you may look at those two seedlings and say, well, half the battle was getting them up out of the ground. You got both of them there. And there's really not that big of a size difference there, or is there? The question for today is this a yield penalty? These plants with a 12-hour difference in timing, is there a yield penalty here? You know, as I was putting together this presentation, I got to the point and thought, I'd like another opinion. And so I reached out to Ag Twitter. I went to my Twitter account and I just typed up a poll. And I said, hey, I'm working on some PTI farm trial results, specifically corn emergence timing, and would love your guys' opinion. On your farm, what is the acceptable variance in plant-to-plant corn emergence timing? And the answers to the question, I put the same as our flag protocol, the 12-hour increments, 12, 24, 36, and 48. And I thought the survey poll results were very interesting. 18% of the people who voted said, I want them up as fast as possible. 12 hours is what works on my farm, or at least what they want on their farm. Almost half the group, 46.7%, said, we don't need them up in that first 12 hours. 24 will work fine for us. And then I thought it got really interesting. Almost 20% of the group said, no, we can go out to 36 hours without any yield loss on our farm. And then 16% said, no, we can go clear out to 48 hours. So my question is, who's right? I mean, there's a big variance here, and And I'm glad we did the testing here because I'm going to show you the yield difference in each of these 12-hour categories as we go forward. So let's think about it as the race to 12 hours. When we invite growers to the PTI farm during the summer, I ask them this question every day. Can we get corn up in the first 12 hours? And most guys say, well, I don't know if it's possible, which tells me I don't know if they're out there flagging, doing this flag protocol that we're doing. And so I think we need to pose the question, is it even happening in the field? Can we prove that we can get 12-hour emergence? Does it happen? So all the closing systems that I showed you before, we took them to the field and I monitored 12-hour emergence. Now, again, we're also testing the 24, the 36, the 48 plus, but don't think about that right now. Just focus on the first 12 hours. Now, the data I'm showing you, I'm going to show you a couple different speeds. We're going to start slow at 4 mile an hour, and then we're going to work our way up to faster speeds because we've got a clientele that, farmers using speed tube technology where they want to plant faster. But I'll start slow and we'll go fast. Here's 4 mile an hour. Now, to interpret this graph, the blue bar on the right will always be the automated furrow force, okay? And if you look at that blue bar, it stretches up to the top and goes up to 92%. What that means is 92% of the plants that were closed with furrow force came up within the first 12 hours, 92%. There was 2 other closing systems that were, in fact, over 90% as well, performed very, very good. But we had 2 closing systems that were right at 80. What does that mean? Well, that means that 20% of the plants came up and were classified as a late emerger, either a 24, 36, 48, or 48 plus. But that's at 4 mile an hour. You guys planting any faster than that? Probably a lot of you, right? Let's hit the throttle on the tractor and let's go faster. Now we're up to 6. And guys, this is where it got really interesting. We started to see a separation of the data. Again, furrow force, the blue bar on the right, over 90% of the plants up, in fact, in that first 12 hours. Performed very well. But now all the other closing systems at this faster speed of 6 mile an hour never hit 80%. Again, at least 20% or more of the plants classified as a late emerger. Let's go faster. Let's bump that throttle one more time. Now we're up to 8 mile an hour and we see the same thing. Furrow force up over 90%. Plants up within the first 12 hours. All the other closing systems, this time we've got some right at 70 and even into the 60 percentile range. 8 mile an hour, you planting faster than that on your farm? We've got speed tube on this planter. Let's go faster, hit the throttle. Now we're up to 10. And again, we see the same thing. Furrow force up over 90%. First 12 hours, all the others 70 or even into the 60 percentile range. Now, all of the data I've shown you so far is corn that's planted at 2 inches in depth. And one of the things we worry about as growers, speed the planter up. Sometimes we lose downforce. If we don't have the right downforce on the planter, the row unit wants to come up out of the ground. And when that happens, we lose depth. We actually shallow up since the row unit's coming up out of the ground. And I said, well, we've got these closing systems. Some of them are lightweight wheels. Some of them are heavy spikes. Some of them have the long fingers. And I said, what happens if we shallow up and still have an aggressive closing system on the backside of the planter? Guys, I shallowed up the planter on purpose at 1.5 inches, and it was a train wreck. Furrow force, probably some of the best numbers in the whole study actually, 95% of the plants came up in the first 12 hours, but look at the rest of the closing systems. Again, I shallowed up here with planting depth. Some of these closing systems in the 40 percentile category. That means that 60% of the plants came up late. They didn't come up in that first 12 hours. So, back to our original question, this race to 12 hours, does it happen? Sure, it does happen, but it doesn't happen 100% of the time. Now the next question is, does it even matter? If I can get a closing system that helps me or allows me to get plants up in the first 12 hours, can I capture any yield? Is there any benefit to it at all? Let's find out. Let's find out if there's a yield penalty for these late emerging plants. What is the true cost of a late emerger? And then how often is it occurring in the field? Well, to figure this out, we go back to the field. We've got our flags in the field from our flag protocol, and we watch those plants all the way through the growing season. And when it comes time for harvest, we don't bring a combine in to harvest these trials. We got to do it by hand. So we bag up all of these ears, these late emergers, the first 12 hours and all the late emergers. We bring them into the shop, and I weigh every single one of them. Our team weighs every single ear. We take the moisture of them and we put them through a sheller so we know what the actual yield is of every single ear in this late emerging study. And here's what we found. 77% of all the plants, no matter the closing system, no matter the depth, all the data combined, I did in fact get 77% of all the plants up within the first 12 hours. Not all of them, not 100%, 77. I had 18% of the plants up within that next 12 hours, if you will, the 24-hour category. And then the numbers crashed. I only had 2% in the 36 range, 1% in 48, and 2% in the 48 hours plus. For today, we're going to say that the 77% of the first 12-hour emergers is the best we can do. I don't know. I probably ought to, at PTI come up with a different test or protocol at the farm to really maybe monitor every hour on the hour the emergence. But today, we're going to say the first 12 hours is the best we can do, okay? That's where we want to be. So now we're going to look at the penalty for being 12 hours behind. Started at 24, going out to 36, and even later at 48 and 48 plus. Here's what we found. When we go to the next 12 hours, so the 24-hour classification, we're losing 12% of yield. We go out to 36, now we're losing 42% of yield. We go out even later to 48, we're losing 78%, and then those super late emergers in that 48 plus category, we didn't give up 100% of the yield, but it was pretty darn close. We lost 90% of yield from those late emergers. And ladies and gentlemen, I want to bring the field to you. I guess the best way to understand this, I guess I'm too much of a visual person. I need to see it myself, and so I want you guys to see this. We brought some ears in that we were getting ready to harvest, okay, from this late emerging study, and I want to show you what the difference of these ears are. We've got an ear board here where we've got each of the 12-hour increments, the 12, the 24, 36, 48, and 48 plus. And we've got a selection of ears from each of these emerging categories. Now remember, we're saying that the first 12 hours is the best that we can do. That is the very top shelf, okay? The one I can barely reach. That's the 12-hour emergence, and look at those uniform ears. That's going to be maximum production. That's what we're shooting for. But what if we don't get it? Now, we're emerging 12 hours later. Now, you'll see the white lines on the ear board. See this white line going all the way across for every category? That represents the average ear size up here in the original 12 hours, that 77% that we're trying to get. Okay? It also shows you how smaller these ears are, okay, to kind of signify that yield difference. But we went out 12 hours later, we got into the 24-hour classification, and we're losing 12%. And you can see some of these ears, we're giving it up in size. And I know it's hard to look at diameter of these ears and the weight of the ears, but just looking at overall size, you can tell they're a bit smaller. It gets worse as we go later. Look at this, 12 hours later to 36, we're losing 42% of yield. And look at those ears. Again, compared to the white line, which would represent the average of the 12 hours, a big difference. Let's go later. Let's go to 48 hours. What do you see? We start to see some really tough looking ears. We go out 48 plus, and this is where, again, we lost 90% of yield potential. And look at these ears. I mean, they're not barren, but they're pretty darn close. These are the guys that came up super late and could never compete. They were the runts that just barely put an ear on them. That's why the yield is so severe. So, to summarize things here a little bit, is there a yield penalty for late emerging plants? You can tell by the ear board here that there's a penalty for every 12-hour late emergers. Okay? So I'm going to say that answer is yes, a resounding yes, but what is the true cost? And again, we got to go back to this baseline control. I do think the 77%, okay, that's the best we can do, so I'm not going to worry about that one right now. What I am going to worry about, where can I improve? Where can I pick up yield? Where can I pick up profitability? And we got to look at the others, the 24, the 36, the 48, and the 48 plus. I took all of the closing systems and I basically looked at that 24, 36, 48, and 48 hours plus and assigned a yield loss based on the ears that we had flagged as late emergers, and then we shelled them to find out the yield loss in each of the categories, and I put an overall yield loss on each closing system. And ladies and gentlemen, I'm here to tell you, every closing system lost bushels per acre. Every single one of them. Because again, the occurrence factor of the first 12-hour emergence was only 77%, not 100. So every system lost. Furrow force lost 4.1 bushel per acre. But look what happened in comparison to the rest of the closing systems. They're at 11 bushel up to 18 bushel to the acre because they had more late emerging plants. Now, where is the biggest yield loss coming from? Remember the ear board. We've got these plants at 90%. They look like almost barren ears in some cases. You may think that's the biggest yield loss with these super late emergers. I will agree that is a high percentage yield loss when it happens, but remember the occurrence factors. It's not happening as often. So as we look at the data, the highest yield loss is actually coming from what I call the next 12. Not the first 12-hour emergers, but the next 12 that's classified as a 24-hour emerger. And you may be confused by that. Why would that be? Well, it's the highest occurrence factor. We've got 18% of these plants in the population compared to 2% or 1%. There's more of these guys, and so it adds up quicker, and that's where the losses are at. And so I look at this and say, this is where we can improve. I want to get those 24-hour emergers coming up quicker to put them in the 12-hour classification so we don't lose yield. Again, there's that total. 18% of the plants are in that next 12 is what I call it. Not the first 12-hour emergence, the next 12 for a 24-hour classification. That's those plants that we can go after to move them up 12 hours so they're not losing as much yield. Yes, the 36, 48, and 48 hours, that's tremendous yield loss, but it's only happening 1% to 2% of the time, fortunately. So let's put a dollar value to this. This 24-hour, the largest population, I guess, that 18%, right? The ones that I think we can move up 12 hours potentially. If we can't do that, right now our cost per acre is about $18.84. Taking the average yield loss times the price of corn, which this year I'm using $3.75. It's a rolling 12-month average from October 19 to October 20 for new crop corn. That's almost $20 an acre. I'm saying if we can just take those 24-hour emergers and move them up 12 hours, we can eliminate this almost $20 loss that we're seeing in the field. To summarize, are we getting plants up out of the ground in the first 12 hours? Yes. Here's a summary of all the closing systems. Furrow force, 93% of the time we are in fact getting plants up in that first 12 hours, but the rest of the closing systems that we tested this year, not a one of them got to 80 on average with all the testing that we did. So, Corey talked about, Mariano Rivera coming in as the closer to seal the deal, to win the ball game earlier, right? You saw him present on that. What if you bring a closer in that fails? What if you've worked hard all 9 innings and you're trying to win the game, you bring the closer in and say, all right, closer, you go seal the deal, and here's Aroldis Chapman for the Yankees, comes in. It's 4-4. It's in the American League Championship game against the Astros. There's 2 outs, bottom of the 9th. Chapman comes in. Did he get a strikeout to end the inning? No, he gives up a home run, a game-losing walk-off home run. And not only do they lose the game, but the Houston Astros go to the World Series. Not a very good feeling, right? We don't want that to happen when it comes to closing systems on your planter. We don't want them to fail for you. And so that's what we're doing with furrow force. And guys, it comes down to this. This is a very robust system. It's a 2-stage system. That first one, again, Corey and Tristan talked about this earlier. We're going to lift and fracture with that first stage to blow that density layer out of there. And then the second stage, we're going to stitch it back together for good seed to soil contact. We know it takes a 2-stage system, but we're sensing while we're doing this. This is the problem with closing systems we have or have had over the last decade or two. They're fixed settings. Ladies and gentlemen, we're measuring in real time. We're measuring soil variability. This is where we're getting, in my opinion, some of the best yield opportunity. We're measuring in real time, and if we don't have it right, we can react, we can fix it, we can change it, and that's what the sensing with furrow force is doing for us, and we're getting more plants up out of the ground for a uniform emergence timing. I want to thank you for your time today. We've really enjoyed talking the agronomics about closing. On behalf of Corey Mulbauer and Tristan Herman, thank you so much. Thanks for coming to Winter Conference, and thanks for sitting in on this session talking about closing the furrow.
Well, we've had a great day with every one of you here at Precision Planting's 2021 Winter Conference. Thanks for being with us, and let's talk about Build Your Picket Fence Stand. You know, we've been alluding to it throughout the day, but let's actually talk about what does this theme mean and how do you do that with your farm. You know, when we think about building a picket fence, what we actually think about when it comes to the crop is consistent spacing, right? Because those pickets on a fence have that consistent spacing. But there's a lot more to building a fence than just getting consistent spacing of the pickets. Ask any fence builder, and it's how you set the posts that really drive that structural integrity and longevity and beauty of the fence. The pickets simply are that result. So we see these plants here, they're all consistent diameter, consistent height. And that's what gives beauty to an actual picket fence. We don't have pickets that are 3 inches, then 7 inches, then 2 inches wide. They're consistent. The posts are consistent height. Everything's consistent. And so when you build a picket fence, no matter the crop, it's going to drive yield. It's going to drive increased yield and increased profitability because you're going to have more ears, more bolls, more beets, more pods, more seeds, whatever crop that is. So let's actually talk about how building a real fence and building a picket fence stand in your field have some parallels and how we actually do that. First off, we have a toolbox. If I'm going to build a fence, I have my tools. And those tools I'm going to take and have prepared for me to build a fence. And this is your toolbox, the base iron of a row unit. What you see here, that's all you actually need. Okay, so here we see the base of a John Deere row unit. That's all you need to get started. Doesn't matter what color, doesn't matter what brand. And we're going to add the tools to this row unit so you can build your picket fence. When we're building a fence, a real fence, the first thing we're going to do is clean and clear the area where we're going to put that fence. Mow the grass, clear the brush. And that's the same thing when building a picket fence stand. The first thing we're going to do is move residue out of the way. And we saw today this row cleaner Reveal, an exciting new product. And we're excited about it because it gets the row cleaner off the row unit and eliminates the challenges to row unit ride and downforce that a row unit mounted row cleaner provide in your operation. The design of Reveal allows it to keep engagement with the ground so it doesn't bounce over residue. It stays engaged the entire time. I think one of the neatest features about Reveal is that the depth of tines is gauged from the clean surface, not from the surface on top of residue. It's that wheel behind the tines. And then, of course, there's independent tine depth and pressure adjustments. You're going to actually determine how deep those tines engage and set that independent of pressure. So when building a fence, we clear. The next thing we need to do is measure out our fence. We need to measure where the posts are going to go. We need to measure and lay that out. And that's the same thing you do on the planter. As we add sensors to the row unit, that allows you to measure your planter. And in that session this morning, Justin McMenemy and Doug Wiegand talked about how an X-ray helps a doctor medically do their job and get the right diagnosis to fix a medical issue in us. That's the same thing that can happen with sensors for you as the doctor of your planter. And there are 5 things worth sensing. Number 1 is seed. Number 2 is row unit ride. Number 3 is downforce. Number 4 is the soil environment the seeds are being placed in. And number 5 is the fertilizer rate. You know, that soil environment, as Justin talked about, Smart Firmer telling us seed available moisture. And he found in the yield data we have from R&D that our plots 2-inch depth only wins and was top yield 21% of the time. That one size doesn't fit all. But that a sensor can help us get better and move that win rate up. So we've cleaned, we've measured, now we actually need to create the hole for the posts. And that's the same thing we do on the planter, setting depth for our seed trench. We need to create that seed trench. And in the session on depth, a lot of good information there on this product called Smart Depth. And what we first found was that planting at a single depth across all your acres is just like if every one of you were given the best average size shirt. We gave every one of you in this room a large shirt. Some of you would be happy, many of you would not be. And just like a tailor tailors clothing so it fits properly, we want to tailor our depth. So our depth is right for every acre, every field across our farm, because one depth is not right in all scenarios. And then we showed Smart Depth, an innovative new tool to calibrate depth on each row, be able to adjust depth from the cab to save you time. Time is money. And Smart Depth with Smart Firmer drives visibility, confidence, and action so you can get your depth set right where you need to change it and be confident you're doing the best job to build your picket fence stand. Now, when building a fence, at this point, we're going to put a post in the hole. And that's just what we do on the row unit with the seed delivery and seed placement system. So here we see our meter, our drive, and the speed tube delivery system. And those three components can work together to deliver those seeds one at a time, so we have that picket fence stand from a spacing perspective. And in that session with me, we talked about how typically we think if we're going to get better, it drives complexity, but it doesn't have to. It's not a dichotomy. We can have the best placement, the best yield, and a simple to use technology. Well, we've got our seeds in that furrow. We want to make sure that we anchor them. And in building a fence, we would anchor the post. Probably put up a couple brace boards to anchor that post. And that's similar to creating a furrow that can anchor the seed. And creating a furrow is many things, but one of those major components is downforce. It determines the structural integrity of the furrow. And Corey showed us how different downforce settings, actually different gauge wheel weights, affect the furrow and how it's created and the environment seeds will get placed in. And then Caleb talked about how one setting is never going to get all those things right because we have variability in our fields. And we have to adjust for that variability, and that's what Delta Force does. Delta Force is a downforce control product. It's going to adjust for those changes in your field so you get downforce right in every foot on every row, so you have consistent emergence that builds that picket fence stand that we want. All right, so at this point, when building a fence, a lot of times we'd add concrete into the hole to hold that post. And that's similar to what we do on the row unit with adding fertility at this point. We're going to add fertility around the seed so that as that young seedling starts to grow and that plant starts to grow, it has the nutrition that it needs. And in this session on nutrient management, we heard that the team at the PTI farm has done a lot of research, and what we found is, number one, planter-applied fertility drives increased profit. It can be done with the same fertilizer dollar. When we think about moving from maybe off-planter fertilizer to adding some fertilizer being applied with a planter, it's not about more fertilizer, it's about reallocation from maybe fall dry to some being planter applied in the spring. And then the results about planter applied nitrogen, getting that nitrogen onto the planter instead of broadcasting it, drives significant return on investment every time. And it's because the nitrogen is right where the plant needs it. Our plants grow in rows, we should put the nitrogen in bands right around that plant rather than broadcasting it where it doesn't grow. Well, at this point, we've just about completed the process of building the fence, or at least putting the posts in. We've just about built our row unit as well. The tools on the row unit we need to build our picket fence. But you could say we're at the 8th inning and we're ahead. What's the last thing? Well, we need to close that hole up. And around the post, the way we do that is by putting soil back in the hole and then tamping that down. Why do we tamp it? Well, we want to firm it. We want to make sure it has the right density. And that's what furrow force does. It closes and it firms and it comes in and seals the win in the 9th inning. The last part of the row unit that encounters the furrow actually destroys the furrow. And what we found in this session with Corey and Tristan and Jason is winning the race to 12-hour emergence, furrow force wins. And that the most common comment we get from users of furrow force is, I can't find the furrow. And that's exactly what you want in your fields and on your farm, not to be able to find that furrow. We want no evidence that the planter pass was ever made and those seeds are tucked in the soil just like furrow force leads them. That's exactly what we want. So at this point, you could say, well, we've built the row unit, but I don't believe we've completed the fence. We don't have any pickets on the fence. And you're right, because that's the easy part. That's actually the result. Getting pickets on your fence and getting ears, getting bowls, getting pods on your plants, that's the result of all the work we've done so far. So as we see this row unit come together and we see all the significant parts of this row unit that we have to build and we have to assemble and the systems that help us build our picket fence, we see how it's just like building a real fence. Building a picket fence stand and building an actual fence have a lot in common. And the end result is a beautiful fence and a beautiful stand that gives us high yield, high profitability, and looks good. So as we wrap up here, there's a few ways you can connect with us. Number one, we'd love to have you post on social media what your thoughts are on today. We appreciated having you all. We'd love to hear your feedback on the thoughts that you have. You can always visit our website, and we're busy answering those questions that you've texted in. We've had a team that's been answering those, and you've been able to connect with our presenters today. And of course, your Precision Planting dealer. They're the expert in your local area for all agronomy and product-related questions. Inside PTI, Jason Webster talked about this. This is where we share in weekly emails, videos that give trial results you want, agronomy explanations you need, and insights to help set you up for success on your farm. Sign up for this. InsidePTI.com, and you can sign up. And next month, you'll start getting weekly videos that give these trial results. It's a really great way for us just to share with you agronomy information and trial results. We're not pushing products. We're not really talking about products other than that they happen to be used on the farm. It's agronomy and agronomy trial information. As we go today, I have a challenge for you. As you drive home, notice the fences. Look at the fences you drive by. Are they fences that look good? How consistent are they? Are they broken down? Are they not in good shape? And as you go from today, prepare for this planting season, you go through the growing season on in the 2022 growing season, the 2023 growing season, every time you see a fence, I want you to think about your planter. Make that connection between the fence and your planter. And what I want you to look for, and I want you to think about is this. For your crop in any given year, does your planter have the tools? Do you have the knowledge in the cab? And do you have the confidence to build a picket fence stand that you would be proud of and that would be profitable? Well, thank you for coming today. Have a safe drive home. And here in 2021, go build your picket fence stand. Thanks.